Thank you for coming this evening. I hope it will be it is a pleasure to me to present to so many people, and I hope it will be a pleasure to you to listen to me talking about Excel 2013. This presentation is about PowerPivot in Excel 2013, and the idea behind this presentation is to try to show the capabilities of PowerPivot in the new version of Excel, showing some of the new features that we have, including Power View. But the most important part is trying to understand what is the difference in creating a solution by using this tool, by looking at the effort that I have to place in creating and in trying to solve the request coming from a potential customer. Before starting, how many of you are themselves BI pro, BI professional, BI developer, so people who create business intelligence solutions? Many of you. How many of you would say that themselves are more business user, that use Excel as an analytical tool, but they do not know SQL analysis services? Nobody. Nice. This is interesting because you probably will have the same initial judgment about PowerPivot that I had at the beginning. It's a joke, okay? But in reality, you will understand that the technology that is behind PowerPivot, which is also the same technology that we have in Analysis Services 2012 in tabular mode, allows us to solve issues that we always had in a completely different way. And probably saving a lot of time. That means also saving money. Probably I have been already presented. I am a consultant, part of the SQLug.se website, in which you can find white papers, tools, and other useful information, articles about analysis services and PowerPivot. I wrote a few books about analysis services, and the last one, Analysis Services Tabular, is the most recent one. If you are interested in PowerPivot, there is a book about PowerPivot in Excel 2010. It was written for the first release of PowerPivot. I and Alberto are writing a new release of this book that will be ready March, April next year. So it will be on Excel 2013 with PowerPivot and PowerView. So in reality, I already asked the initial question. How many of you work with Analysis Services 2008 R2? Almost everybody. How many of you know what self-service BI is? You heard Microsoft about. How many of somebody of you have already seen the session DAX in action? No? Somebody? Okay, you will see something similar. How many of you already tried Excel 2013? Not so many. Nice. Excel users? Everybody? Everybody. Okay, let's start to some discussion about the history. And if you think about what happened in the 70s, we had a revolution. We moved people calculating things on the paper, and they started to use machines to do that. In reality, the big revolution was not just the introduction of the personal computer. This was a first step. But the most important revolution for many people working with numbers was Visicalc. Visicalc has been released in '78, and it was the real switch from the paper to the computer for any calculation. Any end user, any user that was just an accountant, was able to create his own solution. That was basically what we will call today a workbook, an Excel workbook. But at that time, it was crazy that you were able to define formulas, and you just changing a number, you was able to see the effects of this number in all the cells. Of course, we had many changes in this user interface, but if you think about the calculation and the basic idea, it was the same. But at that time, this was brand new, something hard to use, something difficult to understand for many people. A few years ago, PowerPivot was announced, and the reaction was similar. I and Alberto Ferrari, who wrote with me much of the book, were at the presentation of PowerPivot. We weren't prepared to that, so we have seen this for the first time together with thousands of people in the keynote of this past conference. And Microsoft said, remember, one day you will say, I was there when you presented that. And I and Alberto, you know, we are not serious when Microsoft tried to emphasize too much these things. So come on, you are joking. This is just for simple projects. You cannot really use Excel for doing anything. And you need someone who creates data models. You need a BI professional. What about the one version of the truth of the data warehouses? And we considered that initially as not as a so useful tool. Of course, we changed our idea. And we changed our idea because we understood that Microsoft was trying to do something with a very long-term goal, 10 years, 15 years. And the idea is that after decades ago, people who were used to write things on the paper moved the same calculation to the computer with the workbook. Today, now Microsoft is starting to give to the end user, to the business analyst, to the business user, the ability to create a data model. Not just a calculation, but an entire data model in which you can navigate data, something that we are used to do. Of course, we have a larger knowledge of that. We know how to solve more complex problems. But if you think about Excel, it's the same. How many users in Excel really leverages Excel 100%? A ridiculous small amount of people. But how many users use just a fraction of the power of Excel to do their job? A lot. Look at PowerPivot in this way. You, as a BI professional, will be able to get the full power of PowerPivot. You will be able to move this model in analysis services. You will be able to create very complex calculation because you know what is behind this technology. But if you get many building blocks of PowerPivot, you enable an end user to do many complex things. Now, PowerPivot introduces a new technology, introduces a new language, which is called DAX. DAX means data analysis expression. This was just a formula language in the first release of PowerPivot, and today with Tabular it is also a query language. Again, today thinking about should I write my queries in DAX? Really? I don't have an editor. I don't have. There are too many missing tools today. But thinking long term, you will see many more tools and people using DAX as a query language. As a query language, I mean in reporting services. Instead of using SQL, many people will use DAX. Why? Because we have seen with the first early adopter that the Microsoft theory was correct. People who has a SQL background learn DAX easily. The learning curve of DAX requires some effort, especially if you want to implement complex calculation, but this is just a fraction of the effort that it was required, and it is required to learn MDX, which is much more powerful. With MDX, I can do crazy things. I cannot do these things in DAX, but 95% of the times, I don't need this power. I just need what I can do with DAX. And good news, DAX is also very fast. and sometimes solve problems better than MDX. And we will understand this, I hope, in this presentation. So this is the idea. We do not have enough time in 1 hour to learn that. DAX is simple, but it's not so simple. That can be taught in 1 hour or 1 or 2 hours. It requires 1 or 2 days, some practice. But after 1 month, you already know DAX good enough. In 1 month of MDX, you are just a beginner. You need 6 months, 12 months of MDX in order to be able to say, well, I'm an MDX programmer. DAX is easier. We will try to understand what is the benefit of using DAX, especially when we relate this to the alternative. Which is the alternative to solve the problem that I will show you in other tools, including analysis services. And this is possible in Excel, and of course also in Tabular, if you prefer. And Excel is going to change the rules. So the scenario is based on a very common database. I will start from AdventureWorks. AdventureWorks is a fictitious company that sells bikes all around the world. They already have a data warehouse. With this data warehouse, they have already a star schema. And the star schema is a good starting point. So, as you understand, it is true that I can import data from any data source. But in reality, if you have an existing data warehouse infrastructures, this is the best place in which you can use PowerPivot, because you already solved the data quality problem, the consistency over data, a lot of features. So we start from here. We consider that someone already provided data in a good shape to our user. And Excel today do not have tools to do data cleansing or other data, or to solve the other data quality session. Now, my customer says, well, I want to use this data in a good way. So I want to use a, Excel, a pivot table, maybe some chart, and I need something that I can use. If you give me just tables, I'm not able to do that. And usually we would have started a new project in Visual Studio. We would start a new solution. We would start designing the dimensions, the measures. We should define the relationship between all the entities involved. And as you will see, many of the entities that we have to create in, for example, analysis services multidimensional, really depends on the report that we want to do. So when you design the data warehouse, you have to think about the entity you want to manage. But when you design the data mart, and especially the cube, you have to think about the report that you want to generate. Because you have to provide the right measure, the right dimension with the right hierarchy. Because otherwise, the end user is limited in creating new calculations, in navigating data in different ways. After we deploy this on the server, my end user can start to play with data. But if he tried to look at my job, after half an hour he go to the coffee machine, and after 1 hour he go in another office, and maybe he come back in the afternoon and I still haven't finished my initial cube. And this is the multidimensional experience, which is still good, but it requires skills, it requires time. Now let's try to do the same thing in Excel. And in order to do that, I go in my virtual machine, and I start Excel 2013. In Excel 2013, that it could be new to many of you, is a new release, a new user interface, many new things, but fundamentally 95% is the same Excel that you are used to use. So the difference is that we now have PowerPivot integrated in Excel. This means that if you go here, you have an add-in here. Oh, I forgot to zoom it, sorry. Oh, I forgot zoom it. That is fundamental tool for the presenter. Okay. Here. PowerPivot for Excel 2013, PowerView are installed when you install Excel 2013. You do not have to download something else. The only difference is that at the beginning, when you install this, these two add-ins are disabled. So let's disable these tools now. So now I am in the initial condition of an Excel 2013 user. I have Excel, and I have my tables in one external database. So I get my tables here. An end user is probably used to import one table at a time, and he can create a pivot table on top of this table. And he can use Excel 2010 to do that without using PowerPivot or other things. Now, if I connect to my if I connect to my AdventureWorks database, I can do something new. I can select multiple tables, which means that instead of choosing just one table, I can import many tables in a single operation. Interesting. Let's try. I know that I have, you remember, I have a star schema. So instead of denormalizing the star schema into a single, large flat table, I just start from the sales view. My friend in the IT department created some views in order to simplify my access to the data. And these views contains only a few columns, contains nice names of the columns. So these are cleaned tables with my data. So I get the sales, I get the price bands, I get the, for example, the customers, the products, and the categories, and let me remember if I have to import something else, but I think oh no, and the calendar is import. Okay, now I click next, and now I say, well, I want to finish here, and I want to design a pivot table with these tables. So this was not possible in Excel 2010. You cannot do this because you can import just one table at a time, and you cannot create a pivot table report based on many tables. But this is exactly what I did now. And remember, I disabled the PowerPivot add-in. Okay? So I have now a native function in Excel. I have my pivot table here, and if I get, as you can see, I have many tables here. If I go in the sales table and I drag and drop the sales amount here, I have a number. I can, of course, format this number in a better way. So I can say this is currency. I can use a larger font, and I have my number. This is exactly the total for the sales in the entire table. So in reality, I'm using the engine of PowerPivot because I have many tables, but I have the ability, I should have the ability to put the category name now on rows. If I do that, what happens? Something strange. Because I can see the data of different tables, but at the same time, I'm not filtering the sales by product category. Why? Because I imported data from views. If I imported the same data from tables with relationships between tables, also the relationship would have been imported into my data model, and this would already work without PowerPivot. But because I need to create relationships, I need to, click these yellow things and say, well, I can create the relationship, and again, I can do that without using PowerPivot. Of course, if you do that, you have to do this in a textual representation. So you have to choose the table sales that contains the product key, and the product key is connected to the products table that is connected to the product key column. But again, this is not enough, because then the product table with the subcategory key is connected to the categories table with the product subcategory key. And at this point, it works. Now, this is not, the best way to design relationships, but the end user, if he doesn't import so many tables at the same time from views, probably can start using pivot tables in this way. But what is happening in reality? We created what is called now a data model. And the data model is a PowerPivot data model. And I can look at this model by enabling my add-in that I disabled before. Because if I enable this add-in, what I obtain is the ability to use the PowerPivot ribbon, and I can open the Manage window. And the Manage window is the window that you already know. Slightly different user interface, but fundamentally the same. If you have already seen PowerPivot, this is not so much different than what we are used to see. You have the table view, you have the diagrammatic view, and in the diagrammatic view you can define the relationship in a much easier way. So for example, I want to create the relationship between sales and the calendar. I just get the order date key, drag and drop, and I create the relationship. Much easier. And you can do the same for all the remaining tables. I think I have just the customer key, and I still have another table which is price bands that I do not connect intentionally because I don't have any relationship. I will use this table later. Now that I have defined my relationship, I can go here, and these relationships are working. Remember, you do not need anymore to refresh the pivot table when you do something on in the PowerPivot window, because there is a better integration between the two words. So as soon as you define a new relationship or a new measure, you immediately see this changing the pivot table. At this point, I can navigate my data, and my end user can, for example, say, well, I want to look at data by placing the year here, and I want to put the category as a filter, for example, and after the year I want to see my, for example, month name. And oh look, there is an issue. My month name is a string and is sorted by in alphabetical order, and I don't want to see that. But this is like the common issue that we can have in a calendar table, and we can choose to sort the month name by using another column. So for example, we can say this column has to be sorted by using the month number, and by doing that we can obtain as a result that going here, remember, I didn't refresh my pivot table, and this is already working in the proper order. So as soon as you change something, this works. Now, I know that when I click on label, on the year here, I can drill down and drill up, but I had to choose the month name column in the list of fields. If I wanted to obtain an easier way to navigate into data by double-clicking the year, I want to see the month or the quarter, depending on the hierarchy, how can I do that? Again, this is a feature that you can obtain by using the PowerPivot Manage window. You can go in the calendar table, you can define a hierarchy by selecting, for example, the year, the month, and the full date. You define the hierarchy, you call this hierarchy monthly, and after that you go back to Excel. As you can see, the monthly hierarchy is highlighted here. All the other columns are browsable attributes that you can still use, but these are hidden because we assume that the hierarchy is more important. We remove the year from here, we put the monthly hierarchy here, and you can drill down on a year, on a date, and so on, and everything works. I still haven't used a DAX. I'm just using the table modeling and some property, and I can obtain a better user experience. Now think about this. In multidimensional, you would have needed more time just to create the dimensions, the fact table, the measure group, the measures that I don't need to create now. I just get any column containing data in a numeric format that I can drag and drop in PowerPivot, and the measure is automatically created in the data model. And this is the user experience that you have here. So I created this workbook. I'm able to provide this workbook to my business user. I'm a consultant. And my business users start to navigate data. And you know, when users start to navigate data, something happens. They discover they forgot to say what they wanted. They forgot to say, well, it is nice to see the sales. Now I would like to see how many customers I had. And well, if I created this model in multidimensional, chances are that I don't have a measure for the customer. Customer is a dimension. I didn't create a measure group to count the customer. So this simple request produces a need for a change in the data model in the cube, because you have to add a new entity, not just a measure. But you have to deploy this again, you have to process data again, and so on. What if I use Excel? By using Excel, I say, well, no problem. You want to just count the customers. So I can go in my PowerPivot window. I can go here in the customers table, and I can write a new formula. You can write a measure in the measure grid in this area. And this formula is num of customers is count rows of the customer. And I see a number here. Sorry, customers without dim and with a final S. Okay. You can see here a number, this number, and I give this number to my user, and I proudly say, well, you asked me the number of customers, and I provided you the number of customers. My end user says, oh, nice, we have 80,000 customers, so let me see the customers by year. And he says, wow, this is not the right number. This number is not correct. And I say, well, you asked me the number of customers, it's the number of rows. No, wait, I wanted the number of customer who bought something. Oh, you asked me for the number of buying customer. It's a different thing, you know? Details is important. So you need to make a calculation of the customers that appears at least once in that period in the fact table. You need a distinct count calculation, right? So what we can do is changing this formula. We can add another measure that makes another calculation. But before that, think about what would have happened in multidimensional. New measure group, new measure, distinct count measure, which requires another read of the table with an order by the customer key. And every distinct count measure is a pain in multidimensional. The num of buying customer, let me highlight this one, is fundamentally equal to the distinct count of the number of the customers that are the surrogate key that we have in the sales table. So if I write sales customer key, fundamentally I'm going to count how many distinct customers I have there. Okay? Now I go back here, oops, in Excel, and I put my, let me close this one. I put my num of buying customers here, and it seems way better now. So I can remove the num of customers. But at this point, I have someone who say, Marco, you know, I look at the number of distinct customers in this month. I count this, and the number is not correct. Wow, why this is not correct? And when you look better into the data, you discover that you counted the surrogate key. You counted how many distinct versions of the customers you had in a particular period of time. Because every customer, one customer has a different name. If he moves from one city to another city, he counts as 2 customers in this formula. And in order to solve that, I will not explain you how it works, but the idea is that that if you want to count the num of SCD customers, this is fundamentally simple, because the num of slowly changing dimension customer means the real number of distinct customers is the distinct count of any column in the din customer table that contains the identifier of the customer, and we have the name. So the customer's name is a column that contains a value that does not change if the customer just move in another city. And by looking at this number, you can see that this number is slightly, oops, oh yes, here it is. This number is slightly smaller than this one, because I'm avoiding to calculate the same customer multiple times. But the problem is that I want to see this number as buying customers. Now this becomes a little bit trickier. The first 3 measures in DAX are easy for everyone. The 4th measure is not so easy, but in this case I want to transmit the message to you that it is just a formula. Then you need some time to understand how to write them, but num of SCD buying customers is equal to, you have to write a calculate statement that says that the distinct count of customers name has to be calculated in a filter that has to consider only the sales that happened in the same selection of other dimensions. So not so hard. And this number is the same considering the entire data set. If I go back here now, I can see that my num of SCD buying customers, let me remove this measure here, is similar at the beginning, but in a few points we have a different number. For example, in January we have a different number because we are removing the duplicated customer in the same month. Okay? Interesting. So at this point my user is very happy, and we already solved this problem. So now I would like to know, it's nice to see how many customers I had over each month, but it would be interesting to me to know how many new customers I obtained in a particular period of time. Well, think about how to solve this in multidimensional. Think about what you should do. You probably will require to create, there are many solutions, but there are no easy solution to this problem. Because you can write a very complex calculation. You may start to look on internet for some article that describe the same problem with the MDX formula, something like that. But the idea is that in DAX, what we can do is trying to write a formula that do the calculation of the new customers. How can we do that? Again, in this case, it's important to know DAX. And the idea is that the new customers, oops, this way. the new customers is what? Is a calculate. Calculate is the magic function. Every measure begins with calculate. We want to calculate exactly the num of SCD by blah blah blah, the same num of SCD buying customer. So I want to calculate the same number as before, but I want to consider a different set of data, or in other words, I want to consider. Let me do this. It's good to use this formula because of the filter that I will do later, because I want to filter my customers by considering for this period only those customers who bought something in this period but who haven't made any I haven't made any sales to them in the previous period. So the first thing is easy, because I just have to consider the customers that have a calculate count rows in the sales table that is greater than 0. But there is another condition, that is that the same count of rows in the previous period has to be equal to 0. So I repeat the same formula here, but I put equal here, but I add another filter, another change to the filter context. This is the technical definition of this calculation. And here I have to say that I want to consider only the period of time that where the date is less than or equal to the minimum date in the current period. So I write a filter over sales where the sales order date is less than or equal the minimum of the sales order date. So if I am considering January 2011, I want to consider all the sales I made until the day previous to the first day of the month that I'm considering. Okay. Chances are that I've made some mistake. And I have a number. The number of new customer here is 80,400. If I go in the pivot table now and I put my customers new customer here, again let me show this in this way. It doesn't work. Okay, let me I made something wrong. Usually I have okay, I probably made a wrong all calendar, right. I forgot this one. Sorry, it happens. So I just fixed the formula. Second here. Yes, all calendar. Oops. Why? All. Oh, my keyboard has gone. Calendar. And calendar and calendar. Okay. What is happening now? Okay. oh, I have this script in another window that I cannot copy and paste. My God. Nightmare. Let me see what is the error here. Order date, right, because this is just date, full date, and full date. Sorry. Cross the finger, still not correct. Customer, new customers, new table. Calendar. This is not correct. Check this one again. Oh my God, every time it has to go here and put the error. Okay. I forgot this. When I imported data, this value has been imported as a string, not as a data, and so my minimum didn't work. Now I should have this working, okay, and now I should have my pivot table working. Sorry. Okay, seems working. So these are the number of new customers. Of course, the first year all the customers were new, the second year too, but now we have returning customers. And in order to show the returning customer, this time the calculation is very easy. We just have to calculate the difference. So the returning customers is equal to what is the equal to the number of customers here minus the new customers here. Okay. And now I go here in my pivot table. Let me use this one as smaller. I can introduce my other calculation, and finally I have also the returning customers. Again, think about what is the effort required to produce exactly this pivot table with exactly these measures in multidimensional. Every time, just using MDX on existing columns wouldn't be so easy, and you would have required much more effort. Probably preparing data up front, making some calculations, some snapshot, and probably if you make some snapshot, you wouldn't be able, for example, to say, well, now I want to consider only the category bikes, and these are just the customers for the category bikes. It is not easy to obtain the same level of feature and performance. And most important is the time required to design the solution. So we have seen the classical problem of distinct count, customers, count the returning customer, something that for the end user is very easy. And in half an hour, I already solved this problem. Okay? Now, let's try to move further. And another common issue is, well, I can see my data. I can navigate into my data. And for example, I have seen that in the sales table, I can get the unit price. So for example, the unit price, I can put the unit price on the rows, and I can see this. For every possible price of my products, I see the total of customers or the total of sales. How can I look at this data in a more meaningful way? I mean, this number doesn't say me nothing. I want to create groups of prices from 0 to 5, from 5 to 10, and so on. And when I import the data, in reality, I already imported a table that contains a definition of price bands with a minimum and maximum value. How can I use this? Now, PowerPivot allows you to create relationships between tables by only using one-to-many relationship, where each row in a table has a lookup table corresponding based on the comparison of a single column. In this case, we want to create a sort of relationship that is based on a between condition. When you create a query in SQL and you write a join, you can write any statement in a join. You can write between. But the join in the data model in PowerPivot and in Tabular can be obtained by only using a single column that has an equal statement. So there are several solutions to this problem. And the solution that I will use DAX in order to obtain the proper value here. But at the same time, I don't need to show this table to my end user. My end user fundamentally wants to see the price band column, nothing else. So I will hide this column from here, because otherwise now my end user say, oh, I found a price band table here, and this price bands table you have to use all because it is not related to the other tables. It is not shown in the active tab here, but if you go in all, you can see price bands. But if you put price band here, nothing happened. You see always the same value. Now, because I want to make this working, I could try to create a relationship, but if I do that, I have to change all the measures, including a condition that generates the proper calculation for every measure. What I can do is trying to work on the data model. If I go in my PowerPivot window, I can go in the sales table, which is the fact table. Usually you don't add data here, but this is a columnar database, and in a columnar database it is very easy to create a new column, and this column will contain the price band. I want to duplicate the value here for every row. Seems crazy? Okay, but let's try. How can I do that? Again, I calculate, you know. Why? Give me the, okay. Equal calculate. So I want to calculate what? I want to get the value of price band's price band. But I have to filter this value by providing that the value in price bands from value has to be less than or equal to the value of the unit price in the current row of my sales table. So this has to be less than or equal to the sales unit price. And, sorry, comma, and the price bands to value has to be greater than or greater than, not equal, because otherwise we have sales unit price. Sales unit price. So again, I define it. The calculate statement is a formula that applies a different filter or a new filter to a table, and the value statement retrieves the value of that column. In this particular case, values would return a table, but because it is a table made by the single row, if I wrote everything correct, I would obtain just the value for that particular row. Let me see what I made wrong now. Okay. Okay. Let me write, I forgot to filter price bands in this way. Forgive me the syntax. No. What is? Yes. Okay. And I call this column price band. Because I don't want my user to be confused by two columns named price band, I also hide this table from the client tools. So my Excel frontend will not be able to see this. Now that I have this value, I can go back to my pivot table. I can go in my sales table that now has the price band attribute, and I can filter data by price band. I see only very high because I had a filter here on products, but now that I include all the category names, I see the split of my customer that bought a product for every price band. Now, what is interesting is that in this visualization, every customer could appear in multiple price bands. And in fact, if you see here, this number is higher than the sum of these values, because the same customer bought something that was a low price and something that was in a higher price. I never reprocessed my data model. I never read data again. I just added a formula. I just added a new column now, and this column allows me to filter data. So you add a new column, you extend the definition of the data, of the data model, if you want to add something that can be navigated and can be used to slice your data. And by doing that, in multidimensional, think about what means adding an attribute in a dimension. You have to process the entire fact table. I didn't reprocess anything here. I just added a new column. And another important thing is that you may think that I'm crazy because I duplicated a string in potentially million of rows. In this case, just 60,000, but I could have 60 million of rows. But this is not true. Because in reality, PowerPivot and Tabular compress data storing a dictionary of the distinct values, that are just 5 values, and store an index to this dictionary in the minimum number of bits possible. In this case, 5 values, I need just 3 bits for every row. Moreover, there is another compression for which if many rows, contiguous rows, have the same value, there is also another compression that further compress data. You have a very high compression of data in Tabular and in PowerPivot, especially for the columns that have very few number of distinct values. So to me, it's more problematic to compress this column than this one. Even if at first sight you may say, oh, this is a string, it requires more space. It is not true. The dictionary is more important than the data type. The data type is not important at all. And building a denormalization of a column in this way in the fact table is more efficient than creating a relationship with another table with 5 rows. Internally, a relationship has a cost that is higher than this denormalization. So again, this has an impact on the way you think to model data. But the point is that, again, I generated my analysis of price bands without touching SQL, ETL, or other things, and without breaking any existing report, without giving an interruption of the service. I extended my data model without touching anything else. And we can use all we have seen to do another step, which is think about ABC analysis. What is ABC analysis? The idea is to cluster data, to create groups of data based on, for example, on the category of data that can be determined by the importance. So if you sort your products or your customers by starting from the product that has the higher revenues, and then you sort the products by revenues, if you consider the running total, you will always see a curve like that, a logarithmic curve. And if you want to know what is the minimum number of products or customer required to reach 70% of the total of your revenues, you just get the point of the curve that includes the minimum number of products for this type. Usually, marketing do a lot of ABC analysis for customers, for products, because they can apply different, for example, if these are customers, customers in class A are those customers that I will try to spend more in order to retain them. Fidelity card, bonuses, something like that. Class B is what is required to go from 70% to 90%, which is usually a larger set of data than class A, but class C is the remaining 10% of revenues that usually requires a lot of products, a lot of customers to be reached. And so we may use different approaches in advertising, in marketing, according to our customer class. For example, we could use the class of products to see our customer, how our customers split their the acquiring of the products. In Excel, this is very easy. In Excel, you just put the product names here. You sort the data by the total sold from each product. You create an incremental running total, which is simply the calculation of the value in total sold in the current row plus the value of incremental in the previous row. And you compare this value with the grand total, which is the sum of the total sold. And when the percentage is less than 70%, this is a product in class A, otherwise in class C, in class B, or otherwise in class C. Now, if you think about this problem in a traditional BI solution, you have to do a complex thing, because we want to put ABC in a dimension, but the ABC calculation is a long process. We could solve this in SQL. We create a SQL statement that does a group by product and calculate the sum of amount over the entire fact table, which could be million and million of rows. We use the temporary table created in this way to update the percentage and the ABC columns in the dimension, and then we can process our cube. But this could have a very high cost. If you have a cube in analysis services, you may think to leverage on the cube to simplify or to have a faster query for calculating the total sales for each product. But in order to do that, you need to process the cube one time, then you run an MDX query, you get the result from this MDX query, you store this result in a temporary table, and you use this temporary table in SQL to update the dimension. And after that, you have to process the dimension and maybe also the fact table again. So you need to run you need to run two processes of your cube in order to get this single column updated. Still expensive. Still requires a lot of skills to do. Let's try to do this in DAX. And let me check just the script. 1 second. I want... OK. OK. So, the problem is that I would like to copy these formulas later. Let me see if I have them. I should. Because I'm not so lucky this time. OK, I will try to remember the formula. OK. So, the starting point is that we have our PowerPivot data model. And we can add a new table. Sorry. We can have data existing connection here. Because I read data from SQL, I have an external connection to SQL Server. And this is what we had also in Excel 2010. But now you see here a new tab, Tables, that shows me the tables that I have in my data model. Now I can get, for example, the products table here. And I want to dump this data in a table. So this is a table that I extracted in Excel from the data model. What I really need to do in reality is just get in the product key and the total of sales amount. And once you have this table, you can do in Excel 2013 a magic thing that is edit text. So you go here, you go in the table, and you edit DAX. Now, this table is just a table of products. I can say this is DAX. And I can write a DAX expression that says, for example, evaluate. Let me think. I can write summarize sales. The problem, I have to remember the name of product key, product key. And of course you have to know DAX to write this one, but you could also, I will show you that sales sum of sales amount. Okay, let's see if it works. Okay. Okay. I created my list of product keys and the value of sales for this product. This is the total sales for each product key, which is the only thing that I need. Okay. Now, this is Excel, right? So I can use Excel to do the following part. Now that I have the total, okay, I can format this in a better way, but I can say, no, why this thing? $. Okay, I like it more. I can add a new column to the right, and this is the increment, the running total. Oh, I forgot one important thing, sorry. Let me remove this column. I should have sorted the data in the right way. I forgot an order by. Order by sales desk. Let me see. Yes. Sales desk. Oops. Okay. I have my data sorted in a descending way, which is important because the most important products have to be at the beginning. And now I solve this in the Excel way. I could have written everything in DAX, but now I want to show you something new. So I write incremental, running total, which is fundamentally equal if is error. Let me write in this way. If error. If I have an error writing this value plus this value, I want to get just this value. This formula is duplicated across the column. I'm using Excel. Okay, I'm not using DAX. I use Excel. I use the knowledge of Excel that an end user can have. Now that I have the running total, I have to compare this with the total of sales. So I write equal this value divided by the sum of this column. I don't remember the syntax in reality, but let's hope is correct. And this is a percentage. Okay, good. Now I have to create, so this is the, rename this to perch. Percentage. And finally I create my ABC class. Now the problem is that I'm doing this in Excel. How can I integrate this data with my existing data? I will show this in a minute. So if this value is less than 0.7, then A. Otherwise, if this value is less than 0.9, then B. Otherwise, C. And I have my A, B, C. Nice. What can I do now? Well, this table has a name. that is provided by default table product, but this is ABC class, ABC products. Okay? And I say, well, add this table to the data model. Now my data in Excel have been moved into the data model. And if you think for a second about what I did, I imported data from an external source. I obtained with a DAX query an extraction of this data in Excel. I applied changes to calculation in Excel to this model, and I imported this data back again into the data model. If I refresh my connection, everything is refreshed in the proper way. It is very powerful because it gives to the end user the ability to implement his knowledge about Excel and push the result in the data model. Now I can say, well, I just want to go here and say, for example, that I have many choices at this point, to tell the truth, but I think that the smartest thing that I can do is creating a relationship between the product key here and the product key here. Because in this way I can also see what are the products in class A, B, C, because I filter the ABC class, then the products, then the sales. I just hide the columns that could make my end user confused. So I hide from client tools. I go back in Excel. I go in my pivot table here. I remove the price band and I put my ABC products, ABC class here. I remove this one, ABC, and if I want to look at the product, I just get the products here and I put my product names here. And I see also the names of the products. And this is very, 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 very powerful. Okay? Not because of the end result, but if you follow the steps, I can enable my end user not to learn DAX, but just using his knowledge about Excel. Of course, this works only in PowerPivot. You cannot get this result and import it in a tabular model. It doesn't work, of course, because the result of Excel cannot be dynamically calculated in a tabular data model. But this is really, really interesting. So, okay, we have seen this DAX and Excel, and now we move to other features in Excel. Now, we have seen the data modeling part, which in my opinion was the most interesting one. But now that we have seen, we have created our data model, we can use another important feature in Excel 2013, that is Power View. Let's see how it works. You have this Insert Power View ribbon when you have a PowerPivot data model, or when you connect, when you have a PowerPivot data model, when you connect it to a tabular data model, you have this tool integrated in Excel that allows you to navigate into the data. What does it mean, navigate into the data? For example, I can get the category, like the category name here, and I can integrate also the sales amount, for example, here. I can enlarge the font. So this is a simple table in this case, not so much interesting. But what I can do is, for example, let me choose not just the category but also the subcategory and reduce the font a little bit. I can try to look at this data with a column chart. So in this case, I can see how my data is split considering the categories and the subcategories, for example. Now, if you look at the data in this way, it seems not so much interesting. But if I put other information, for example, the customer education, and I move the customer education here in another table, and I put the sales amount here, and then I put the let me see if I have the information. I put the customer, I don't have this one. Okay, I have to go to another demo for that. Okay, let me see if I get the customer, the product, the color, the product color here. Oh, not here, but here. And I put, for example, the order quantity. Okay. Now I create a pie here, and I create a bar chart here in this way. Now, if you click on some element in one chart, you apply a filter in the other charts. And you can see, for example, considering the customers in this, let me see if I can go in higher. Okay. If you consider the customer that have bachelor education, how they are split across the subcategories or across the colors? No differences. So there are no correlation between the education and the color. If I click on a color, I can see if there are other distribution of data that are stranger than usual. And this is interesting because it allows you to see the correlation between different measures and different dimensions in an interactive way. This is interesting because it enables you to discover relationships between data, not just by looking at the numbers. So you should not see PowerView as a reporting tool to generate static reports, but to generate dynamic reports, something that can be used in an interactive way. Okay? PowerView also has the ability to use maps. So you can get a workbook. Let me see if I have an already something that I already prepared before. And in this case, I started with the geography that has the information about the country, the city, and other things. If you get this information, if I have them, yes, no, oh yes, okay. Now, I hope that the internet connection is working, and probably no, because I see the problem here. But this is my virtual machine. I can show you this in my physical machine. Let me start Excel 2013. There is internet connection here. Because my virtual machine worked on a wired connection on internet. So for this reason, it wasn't working. So if now I open recent workbook. No, come on. It is completely blocked. It's tired. Come on. What is doing? Okay. Computer. This one is the folder. Let me see. Okay. It should work. Cross finger. The interesting thing is this one. In my data model, I didn't have information about geographical position of elements. So I didn't know where each customer is. I just have the knowledge about the country name, the city name, maybe the address. So what happened when you, for example, click here and drill down at the city level? In reality, the content of the tables is used to query the Bing service and to obtain the point in the map of the name of the city, of the name of the country, or of the address. So if you go down here, you can see the address of each single customer. Now, this is not done very well because this is moving in another place, but the data quality is not good. But if you have good data quality, you obtain a good solution of that. If you know latitude and longitude, you just have to put the 2 columns here, and you will use the data that you have in your database. But this is interesting because I'm using a client tool that is generating a queries index, and this tool can use my existing data, not new data, not data that I don't have now or that I have to buy by someone just to georeference the data. What is more interesting is that this tool can work, this tool will work also with multidimensional cubes, with cubes defined in analysis services multidimensional. Microsoft already worked on a version of analysis services multidimensional that accepts queries index. And this will enable this tool to work on existing cubes. The only thing that you will have to do is deploying the existing cube to Analysis Services 2012 when the new upgrade will be available. A few months away, but very soon, a few weeks, we will have a public CTP available to everyone to test this.
Will that be Service Pack 2? Or?
Microsoft didn't say if this will be a service pack or not. But it will be before the next major release of analysis services, and probably we are months away from that. Okay? Okay. Let me go to finish this. So we have described that we can obtain this data even if we don't have the latitude and longitude in our data. And now, what if I want to send this information I want to share this information with someone else? Well, what you can do, and for this I have to go back to my demo machine, you can save this workbook into SharePoint. So if you just let me go back to my initial one. If I save this on SharePoint, and I go in my report gallery, the report gallery is a PowerPivot gallery, Stockholm. I saved my workbook now. My workbook contains both Excel and PowerView report. If I go in this report gallery, I refresh this because I just saved a new workbook. I will see that I have a new workbook, Stockholm. The preview of this workbook is in preparation behind the scene. If I open this workbook with a simple browser, Internet Explorer, Google Chrome, Mozilla, whatever, also an iPad, to tell the truth, what you obtain is that Excel services produce the rendering in HTML of my pivot table. And by using Silverlight by now, you also see the data. You can navigate into the PowerView data. By now, PowerView is using Silverlight, but Microsoft already announced that there will be a mobile version of PowerView that will be a native application for iPad and Windows 8. It will be an HTML5 rendering option for Android and other tools. And you will have the same visualization of PowerView that you have here. Now this is running in Silverlight by now. But the interesting part is that this one is not Silverlight. This one is HTML. And in in Excel 2013 with SharePoint 2013, you can not only navigate into the dimension that you put in your pivot table, like you can do in SharePoint 2010, you can also change what you show in the rows, and you can navigate in a completely different way in your data. This was not possible in previous version of SharePoint and Excel services. So you can actually browse your data in a free way. Sorry?
Can you refresh the underlying data?
Yes. I'm using now PowerPivot data that I saved on SharePoint. But by going back here, I could schedule a refresh of my data. So I can say, well, I want to refresh my data every day, for example. And at that point, a worker thread in SharePoint will run. Okay, I have to enable the data refresh. I have to make a decision about the schedule of this data refresh. And original connections will be read from the external data sources and will be used to update my data. And it just works. Of course, if you move this model to tabular, you can refresh the data with the timing you want. For example, you cannot refresh data more than once a day with the default user interface. There are workarounds to refresh data more frequently, but this is not supported by default. Okay. Let me go back here. And so this is the way we can share data. So we have a simple relational data model. We no longer have dimension, attributes, and hierarchies. It is important to leverage calculated columns. We use calculated columns to enrich the data model with new ways to split data, to navigate data. And the speed of the query is very high, also with a very larger amount of data, because DAX is very fast. So in 78, people was afraid of that. Today, people is afraid of PowerPivot sometime. But in 10 years, 15 years, probably it will be normal, at least to build simple data models for many people. And of course, the importance of the data warehouse is still here, because only if we have good data quality, we can obtain good result in our analysis. And it is not easy to think that any user will be able to clean data, to resolve problems of matching data of different types, and so on. So self-service BI is not going to replace the corporate BI. It's going to work side by side, enabling the end user to do more with the data they have. But of course, for standard reports and for very high controlled quality of data, tabular, multidimensional will be still important in this road. But of course, workbooks that are built by user with self-service BI can become tabular models in analysis services if they are used by many people and you want to control more. What is important in this direction? First of all, learn DAX, because DAX is the language used now in PowerPivot, in tabular. It will be used by the mobile devices that will connect to tabular. You will see many more tools using DAX to manage queries for the data. So DAX is important. It will become much more important. But tabular and DAX are not a solution to all the problems. We still have a lot of problems that are better solved in MDX in multidimensional. Think, for example, to many complex calculation algorithms that are very based on hierarchies. Hierarchies are not part of the data model in tabular. And this is a limitation, of course. But the data model is simpler in tabular, and it can be used also by advanced Excel users, I think. Thank you very much. If you have any question, we can make a break, but I'm open to all of your questions. Okay? Thank you.